Hello, this is section 9.1, Solve quadratic equations using the square root property. Recall, a quadratic equation is an equation of the form ax squared plus bx plus c equal to 0, where a is not equal to 0. Part 1. Solve by square root property. Square root property. If x squared equals k, then x equals the square root of k or negative square root of k. It can often be written as plus or minus the square root of k. On your online homework, just read the directions to see how they want you to type it. Example 1. Solve the following equations using the square root property. Part A, x squared minus 48 equals 0. So I'm going to add 48 to both sides. Get x squared is equal to 48. Take the square root of both sides, and then we get the absolute value of x is equal to the square root of 16 times 3, which means x equals 4 square root of 3, or x equals negative 4 square root of 3. Notice how I broke the 48 into 16 times 3 because the square root of 16 is 4. Part B, 3z squared equals 108. So I'm going to divide by 3 first. Get z squared equal to 36. Take the square root. Get the absolute value of z is equal to 6. So we get z equals 6 or z equals negative 6. C, x squared plus 72 equals 0. So I'm going to subtract 72 from both sides. Get x squared equal to negative 72. Take the square root of both sides. Get x, absolute value of x, equal to I square root of 36 times 2. So we get x equals 6i square root of 2, or x equals negative 6i square root of 2. Part D, q squared equals 24. Take the square root of both sides. We get the absolute value of q is equal to the square root of 4 times 6. So we get q is equal to 2 square root of 6, or q is equal to negative 2 square root of 6. Part E, 3/4 y squared minus 3 equals 18. Add 3 to both sides first. 3/4 y squared equals 21. Multiply by 4/3 to get rid of the 3/4. And remember, when multiplying fractions, always reduced first. It makes the multiplication easier. So we get y squared is equal to 28. Take the square root of both sides. We get the absolute value of y is equal to square root of 4 times 7. So we get y equals 2 square root of 7, or y equals negative 2 square root of 7. Part F, 3t squared plus 6 equals 70. So I'm going to subtract 6 first. 3t squared is equal to 64. Divide by 3. T squared equals 64 over 3. Take the square root of both sides, and we get t is equal to 8 over the square root of 3, or t equals negative 8 over the square root of 3. Sorry, I skipped a step. You would get absolute value of t equals 8 over square root of 3 first. But now you should always rationalize your denominators. So we'd multiply by square root of 3 over square root of 3, and multiply by square root of 3 over square root of 3. So we get t is equal to 8 square root of 3 over 3, or t is equal to negative 8 square root of 3 over 3. Part G. 3 times the quantity a minus 3 squared equals 54. So I'm going to divide by 3 first. We get a minus 3 is equal to 18. Take the square root of both sides. Get the absolute value of a minus 3 is equal to the square root of 9 times 2. So we get a minus 3 equals 3 square root of 2, or a minus 3 equals negative 3 square root of 2. Add 3 to both sides of both equations, and our final answers are a equals 3 plus 3 square root of 2, or a equals 3 minus 3 square root of 2. Part H, x minus 1/3 squared equals 5/9. Take the square root of both sides. Get the absolute value of x minus 1/3 is equal to the square root of 5 over 3, because the square root of 9 is 3. And then this becomes x minus 1/3 equals the square root of 5 over 3, or x minus 1/3 equals negative square root of 5 over 3. Add 1/3 to both sides of both equations. Thankfully, all the fractions have a common denominator already, so we get x equals 1 plus the square root of 5 over 3, or x equals 1 minus the square root of 5 over 3. Part I. 2 times the quantity x minus 2 squared plus 3 equals 57. So I'm going to subtract 3 first. Get 2x minus 2 squared equals 54. Divide by 2. Get x minus 2 squared equal to 27. Take the square root of both sides. We get the absolute value of x minus 2 equal to the square root of 9 times 3. So we get x minus 2 equals 3 square root of 3, or x minus 2 equals negative 3 square root of 3. Add 2 to both sides of both equations, and our final answers are x equals 2 plus 3 square root of 3, or x equals 2 minus 3 square root of 3. Part J. The quantity 2t minus 8 squared equals negative 10. So I'm going to take the square root of both sides. That becomes the absolute value of 2t minus 8 equals I square root of 10, which breaks up into 2t minus 8 equals I square root of 10, or 2t minus 8 equals negative I square root of 10. Add 8 to both sides, to both equations. We get 2t equals 8 plus I square root of 10, or 2t equals 8 minus I square root of 10. And then divide by 10 on both sides of both equations. Sorry, divide by 2, not 10. So we get t equals 8 plus I square root of 10 over 2, or t equals 8 minus I square root of 10 over 2. Now, it looks like you can reduce the 8, 10, and 2 all by a factor of 2, but because the 10 is in a square root, you cannot do that. Now, part K and L may not look like we can use the square root property because we don't have a single quantity squared. But we are going to use factoring to make these square root property usable. So for example, 4n squared plus 4n plus 1 is the same thing as 2n plus 1 times 2n plus 1 equal to 16, which then becomes 2n plus 1 squared equal to 16. Take the square root of both sides. Get the absolute value of 2n plus 1 is equal to 4. 2n plus 1 equals 4. Or 2n plus 1 equals negative 4. I'm going to go quickly through this now. So our first answer is n equal to 3 halves. And our second answer is n equal to negative 5 halves. In part L, 9m squared minus 12m plus 4 equals 25. So again, this will factor as 3m minus 2, times 3m minus 2 equal to 25, which is 3m minus 2 squared equal to 25. Take the square root of both sides. Absolute value of 3m minus 2 is equal to 5. So we get 3m minus 2 equal to 5, or 3m minus 2 equal to negative 5. And one more time, just going a little quickly, we get m equals 7/3 for our first answer. And we get m equal to negative 1 for our second answer. And that is the end of section 9.1 notes.